Hello, my name is Corey Applegate, mentor of the Granite City GearHeads, Team 3244 out of St. Cloud, Minnesota. Welcome to video 5 of our 2020 robot chassis Fusion 360 build. Last week we assembled this example axle assembly. This week we are going to start assembling the different sub-assemblies that we've built. We're going to start a new file to start bringing in our components and as assemblies. We're going to find a small problem with our drivetrain assembly. It has to do when we grounded the chassis rail during the construction of that assembly. When we bring that chassis as an assembly into a new project, we will not be able to properly ground that in there, and we will not be able to constrain that chassis to the origin. Let me show you what that is and how we're going to fix it. So starting a new application, we're going to, and again, before we start, we must save the file before we can start importing assemblies into our project. So hitting save, I'm going to go select my file from this project. I'm going to go give this a name of, I don't know, 2020 chassis. Save. Now I can begin to start bringing in those parts. I'm going to go find my drivetrain that we've been building and drag that into the project and just place it directly as it's dropped. You can see that this drivetrain is now dropped in as an assembly into our chassis file. This chassis or this drivetrain frame are free to move amongst, but we want to lock it in place. So if we go ahead and try to, I'm going to bring it back to the origin, do as we did before, select a component or even select this assembly and ground the entire assembly, the assembly still is allowed to freely float around inside this project. What we need to do is go remove the ground constraint in the original file. In our drivetrain assembly, we see that we grounded the left drive rail. If we go ahead and remove that grounding, this whole assembly now can float inside here. What we can do is apply an as-built joint, selecting that drive rail and the top level of this project tree to lock this assembly into place. Hitting save here, we can go into our chassis and we see that there's updates to be had. We can go ahead and apply those updates. So now this is locked into place because it's grounded. This is not necessarily a bug in Fusion 360. It's how the computations work. So even the ground that we applied here probably is not the right way to go about doing it. So we're going to unground this. So this is now going to float again. Undo. And I'm going to do the same thing here. I'm going to do an as-built joint, selecting the drivetrain subassembly and the top level of the project tree, the rigid group. Okay, so now this is locked into place. So as we build our robot and we drag this chassis into the next level, we won't have that same anomaly where grounding the assembly does not obey the command. So with that locked in place, we can now look at bringing in our axle assembly that we created last week. That is stored in our Fusion 360 Meetup Assets Library Assemblies and our example axle. I didn't want to open it. I want to drag it in. We can drag that into our assembly. And now we can treat this like any other part, dragging it somewhat close to where we're going to want it. But I'm going to allow myself some room here so I can see inside. Okay. I now want to attach this component to the drive rail using one of our joints. I'm going to select the joint command. I'm going to select the slider joint, since that best represents how this bearing block works with the drive rail. For the first position of the slider, I'm going to zoom into this bearing block to find this inner edge nearest the notch. Center joint origin as my first point. With these corner wheel assemblies, we typically put the notch at the bottom of the rail to raise the axle up. Since I'm dealing with the inside edge here, I'm going to pan around and pick the bottom corner here. Once I have it on the bottom corner, I do need to find an origin point. I can hit Control and it'll snap to the nearest one along this line. And you'll see that this block now has an animation showing us roughly how it looks. We don't want it to be snapped all the way to the corner by default, so I'm going to grab this little arrow here and drag it along here and just roughly try to get it placed. Centered in there. And if I want to be a little bit more particular, I can probably try manually entering some numbers. 3.4 seems fairly close. Okay. And you can now see this block will slide on this rail. There are a couple of things we want to do to this assembly before we copy it and place it on the other three corners of the robot. One of them is if we look at it from the top of the robot, we can see this axle is way too long. We don't want to modify our source file, so as we build robots in the future, this actual axle will always come in as it is purchased. So what we're going to do, we're going to break the link of this assembly from its source and all of its containing components. So any modifications you make in this current setup will not affect the source for use later. Doing that, I can right click on in the project tree, break link. I want to break the link for all the subcomponents because what we want to do is cut this axle. So including subcomponents. Continuing, just that way it'll snap back from where we moved it. Looks like we lost a joint there. Let's just activate this assembly and reapply that revolute joint. I'm going to select this edge here as my first point, and then I can select this inner edge of this circle, and the last joint we were using a slider, let's change that to revolute, and that looks appropriate. Okay. So now what we want to do is we need to find this plane that this bumper mount sticks out as, and we're going to cut this axle off just slightly behind there so that any fasteners that we use will not extend beyond this point. How we're going to do that is I'm going to return back to the top level of this project tree, activating the top level component. I am going to create an offset plane. I'm going to select the face of this tube, and I'm going to type in there -0.1. Okay. And now, if I activate not the Versa block, but the hex shaft, I can use the split body tool to select the shaft. The splitting tool will be that offset plane we created. Okay. Now we can see inside this bodies of the Versa chassis hex shaft. There are two bodies, the main and this outer. We can now remove that outer section, leaving behind just the normal axle. I can go back to the top level to get that plane out of our way because we no longer need it. I'm going to shut off that construction plane. We see now that we have this bearing assembly that can slide freely the entire length of our chassis rail. But what we need to do is apply some joint limits to animate this and better represent how it will be on the final robot. I'm going to undo that manual movement. And since we constrained the inside block, and that's where the joint limit is, I'm going to pan around so I can see that backside a little better. And so as I'm making these changes, I want to be able to see how this assembly looks in the slot. I'm going to go and use the section analysis tool, selecting the face of this tube as the surface I want to see. And now when I go hit the slider edit joint limits, I can expand the min and max. Knowing that this tube is a 1/2 inch long, I'm going to try to place 0.25 as the minimum, -0.25 as the maximum, turn on the animate. Oh. Looks like minimum is going to be a -0.25 and maximum is a 0.25. And I like how that looks, so I'm going to hit OK. Now we can see I can only slide this forward and backwards that 1/2 inch. I'm going to turn off the analysis for now. And now what I'm going to do is copy this assembly. Continue to the front. And since I'm going to need to apply some joints to it, I'm just going to pull this out so I can see the inside features of the inner bearing block. Okay. And now I'm going to repeat those same joints, making sure I'm selecting the slider. This is where we have a decision to make. Again, with the West Coast style chassis, we use the drop center. If we use all high grip traction wheels for all 6 locations, this will most definitely be the absolute position we want this to be. But since we typically use Omni wheels in either the front or back section, we will flip this bearing block over so it's at the same level as the middle axle. We can still go ahead and find that joint origin on the center here, but instead of locking it to the rear back edge of that tube, we're going to lock it to the rear top edge, or the inside top edge. Once we find that plane, or that line, that edge, we can hit control, it'll snap to the nearest, and we can see it starts to animate. It's not quite as we want it, so we will want to get a view here from the front and change this angle, flipping it over 180. And I'm going to drag it in somewhere close, -340, as the rear was. Okay. What happened there? Looks like we may have to go edit that slider. Edit joint. Oh, I see. We need to flip that 180. And probably put this back to 180 to get the block where we want it. Okay. So now this block is free to move anywhere along here. We need to apply those same joint limits to this. The slider, edit joint limits, min max. We'll try a -0.25 here. And a positive 2.25 here. Animate. Looks appropriate. Hit OK. And now this block is locked in. We're going to repeat these steps for the other side, but to speed things along a little bit, we can select both objects, Control copy, Control V for paste, continue. Place them so we can get at where we want to apply our joint. Okay. And now we can apply these joints to these blocks. The joint still on slider. The first joint origin will be the inside block, inside corner, midpoint joint origin. The second point for this one will be this upper edge. We'll try flipping the block. Oh, it looks like we have to try the angle. There we go. Okay. Oh, we forgot to apply that 3.4 to the Z offset for here. Okay. We'll apply the joint. And that inside edge, that joint, midpoint joint origin. select. Number 2, we want this one to be to the bottom. To keep the notch there as well. I got the edge selected, Control, select. And since we didn't move this closer to the perspective, that's why we're having troubles here with these angles here. But we can correct them by flipping and taking the angle to 0. Again, I forgot to put that Z offset, negative 3.4. Positive 3.4. And we can now apply those joint limits to both of these. Okay. And what I've noticed is if you put a dimension in here and it automatically populates the other one, it means that there's overlap and the first value you entered has to be less than the maximum. And it all depends on how the part's placed and where it's deriving the origin to be. Okay. We can leave all these joints independent, so each one moves by itself. Or what we can do is apply a motion link. So when one block is moved, the mirrored side is moved as well. Selecting the joints, I kind of either find these arrows, or if we had did as I always say, named our joints so we know what they are, we could have picked them from the side here. Right now, we set the ratio 1 to 1, and if these were gears, we had set the ratios according to the gear, and I reversed them so when one's forward, the other one is forward. You can now do that same motion link to the other two sliders. One to one ratio, reverse, so they go the same direction, and hit OK. That's all I have for the video today. I would like you to go ahead and apply or add the left drive assembly and the right drive assembly that we have in our assemblies database, and then we will meet sometime in the week and discuss any issues that you've had there.